This video solves the problem from the Project Euler. It's a problem related to palindromic numbers. It asks us to find the largest palindromic number that is the product of two 3-digit numbers. So let's code this in Python and find an answer. So I will define the function isPalindrome. During this function, we will have to interpret the digits of this n, but we cannot do that in the integer format. Therefore, we first need to convert this n to be a string. So n equals strn would be a good option for that. So now let's write a for loop that will go through halfway of this number and check if their symmetric digits are the same. For I in range length of this n over 2. I put two slashes here. It's because we have to do integer division, meaning that it will round the answer from float format to integer format. It's in for loop. Now if the ith term of the number I does not equal the negative ith term of the same number n, then the function should return false. But since it starts counting from 0, we have to add 1 to it, just like this, negative I plus 1. But if this isn't the case, then it will return true. Now I will create a list that will contain all the numbers that are products of two 3-digit numbers, and a palindrome list which will contain all the numbers that are palindrome and a product of two 3-digit numbers. So here's list, it starts empty, and here's palindrome list, which also starts empty. Now for I in range 100 to 999, and for j in range 100 to 999, we will append the list I times j. Now that we create a list of products of two 3-digit numbers, we can iterate through this list and find the ones that are palindrome. So for x in list, if isPalindrome x equals true, then it will append x to the palindrome list. Now we can simply print the maximum value of this palindrome list, which will give us the result. Well, this isn't quite a palindrome number. Yes, here. I stated that it was starting from 0, but we shouldn't add 1, but we should subtract 1, match the symmetry within the digits. So now this should give the correct result. And yes, this is indeed a palindrome number. So let's plug in to Project Euler 9266609. Check it, and it is right.